productionbugfix, GPT-4 vs Claude Opus. Depth determines the true AI advantage. We weren't testing prompt response time. We threw both models into the crucible of a real-world scenario, a subtle, production concurrency bug manifesting under high load. The system was experiencing intermittent timeouts. Users reported successful transactions failing without a clear error log on the client side. The bug wasn't a crash. It was a race condition in our database connection pool management, triggered when multiple threads tried to commit the same transaction simultaneously. We gave them the initial description, intermittent timeouts under load. Need a fix? And here, the models took two wildly different paths. The first round of fixes were predictable. They jumped to superficial solutions, adding retries, increasing timeouts, maybe caching aggressively. These were patches, band-aids on a systemic wound. They addressed the symptom, not the root cause. We escalated the prompt. We injected the thread dumps and the logs showing the simultaneous attempts to acquire a lock on a shared resource. This is where the true divide occurred. GPT-4 recognized the symptom, the resource contention, but remained focused on mitigation. Claude, however, didn't just read the symptoms. It parsed the language of the lock acquisition failures and jumped directly to the concurrency primitives. It correctly isolated the problem, not that they were competing, but the lack of a transactional isolation boundary around the critical section. The surface fix would have been adding an external queue or a database-level transaction lock. Functional, but brittle. The deeper fix? It required restructuring the service to use optimistic locking or migrating the shared state management into a dedicated, transactional layer. This is the difference between a senior intern applying a quick patch and an experienced principal engineer designing a resilient system. We finally presented the models with the core code snippet causing the issue in our server.py file. The issue was here, a try finally block failing to properly manage the connection pool release under exception pressure. GPT suggested adding a semaphore to throttle incoming requests. A valid defense mechanism, but it shifted the problem elsewhere. Claude didn't suggest throttling. It pointed to the specific line where the connection object was being passed into a parallel execution thread. Its diagnosis, the connection object itself was being mutated concurrently across threads while still in use by the pool manager. The suggested fix wasn't a configuration tweak. It was refactoring the connection lifecycle to ensure thread safety primitives were used correctly. It demanded we treat the connection object not as a resource handle, but as a singular, scope transaction unit. This is the difference between a powerful autocomplete and a true collaborative engineering partner. The lesson isn't which model is smarter. It's about the quality of your initial context and the depth of your follow-up prompts. Don't ask for an answer. Ask it to assume the role of a principal engineer, given the context of production failure. Force them to graduate from suggestion engine to architectural co-pilot. If you're building mission-critical software, the LLM is your sounding board. But only if you teach it the language of failure.